let's start this trip. So, my name is Tom Pessala, and I'm going to talk about the risk assessment that we have now implemented at Boule that is compatible with ISO 14971, the newest version. I currently work as systems manager at Boule. Soon it's been a year since I started at Boule. Previously, I've been working at Thermo Scientific in Helsinki with R&D microplate instrumentation, and in Stockholm at Maquet Critical Care with anesthesia and respiratory systems. I've been working with life science and medical products all my career. As system architect, project manager, team leader, and all those positions have contained some kind of technical leadership all the times. At Maquet, I was also part of the team and a team leader for the team that implemented the requirement system at Maquet, but that was using another platform. But the same principles, general principles apply, I think. A little bit about Boule. If you get to a hospital and you have a problem and the physician doesn't really know what you have, then they take a blood sample from you and they send it to the laboratory. And one of the tests that usually are made is that they use some kind of analyzer that counts the red and white cells in that blood. And depending on that, they can draw some conclusions. Eric Helin was the first person in Europe to patent the impedance method in 1956. 10 years later, he established a company called Swelab, and in Boule was established in 1990s and acquired both Swelab and their competitor that was called Nordic. And you can see that on the brands that we are selling today. Hematology. So our instruments look like this instrument, benchtop instruments, small size. We can measure white cells and red cells in human blood and in veterinary blood. At school you learn that there are red and white blood cells, but actually there are many kinds of white blood cells and so on. So that's the information that the physician uses. The system consists of the analyzer you see here, but the analyzer is dependent on reagent that treats the blood so that the measurement can be made. And of course, in the part of the system you have calibrators and controls that are used to calibrate and to control that the instrument references are appropriate. In large hospitals, you have much larger systems than this, but they could use our system for the night shift because they are easier to use during the night when you have the night personnel present. But the more common is that we have our instruments, smaller healthcare labs and doctor offices all over the world. And here you can see the organization of Boule, that is a situation in different parts of the world. We have R&D in Sweden and USA. We have factories in Florida, Spånga, and in Russia. And then we have some sales office. But the main part of our sales goes through distributors. So we have nearly 200 distributors that are selling these instruments. Okay, so let's go to implementation of Polarion at Boule. The previous requirement system is text-based, using Word and documentation system. And there was a need identified several years ago to shift to a database system that would provide also support for traceability and so on. And Polarion was also a candidate to be selected, but it took some years until we managed to start a really good ramp up and start the implementation of this system. So last June, Taipova was contracted, and the decision was made that we should use their medical template. Also, a team was formed to concentrate on this task. And so we managed to implement and validate using Polarion for requirements management. We made that ready in December last year, and we have just last month implemented and validated the risk management area. And now we are starting with verification and validation areas together with change management also. And today it's this area of the risk management that I'm talking about. So those of you who have had a look at the risk management standard 14971, 2019 the international standard was published, and the Swedish one last year. So this picture is from the Swedish standard version. And there has to be a risk management plan and a report, of course. And then you have a lot of activities that you need to do in order to show that you control the risk in your product. It starts with risk analysis. You identify hazards, that is, what kind of dangers could cause hazardous situations. You identify hazardous situations, actual hazardous situation, both as for user and for the design. Then you make risk estimation of those and evaluate if there is a need for risk control or not. If there are need for risk controls, then you need to have some kind of mitigating actions. Perhaps you change the design, you provide better instructions or something like that. And depending on what you do, you can lower that risk. And at the end, when you have done all your risk assessment and your design is ready, you have some kind of a overall residual risk evaluation. And of course, you need to present that in a document and prove that the management has reviewed that. And then you are actually ready to do your risk management report as part of that review. And of course, risk management is active all the life cycle of the product. So you need to have some kind of production and post-production activities to collect information about the product on the field and on perhaps some production problems or issues that could cause risks to anyone using that instrument. And you need to keep track of that, and you perhaps need to update also your risk management file, which is the collection of all the documents that the risk management area generates. And some of these activities we document in our ordinary document system. But these which I have marked here, we are using Polarion as the support. And that is why we're going to the next slide. All of you are familiar with the V model, I believe. Tord showed you a V model 2, and you can find numerous versions of this. But basically, you have the design inputs on the left side and the design outputs on the right side. And then you have different levels of information in this model. And today we are talking about hazards and risks in this model. And to understand how information it is for the model flows, then we need to make a logical model. And this is a visualization of our model we call it the information model. So one starting point is the stakeholder needs. So it's the needs that the product needs to fulfill for the user, market. Production has perhaps some opinions about it, service and regulatory as well. And those needs are broken down to system requirements. And the requirements are put into the design, and when the design is ready, we can do a system verification. Sometimes we do it in-house, sometimes we have third-party verification. And these links, they symbolize the linking that we make in the Polarian requirement system. Of course, we have the risk area as well. And I'm showing this picture so that we can get an overview of how the risk area connects to requirement side. So if we have a hazard identification, we identify hazard, and that generates some hazardous situations that we can see could happen. We make a evaluation. If there needs to be a mitigation, then we create a requirement. So we have a link to a requirement, and then when we have made that requirement implementing the design, then we can make a verification of that design. So that's a simplified explanation for this. The usability standard is linked in the process to the risk management, because you need to do some usability risk assessment, and so you could get some mitigation from those as well, leading to requirements that need to generate. And of course, all new features need to be assessed in their turn, so that all the functionality and all the design has been assessed. So if you start with the hazard identification, we have a separate live doc for that, and where we collect all the hazards. We call document hazard identification as the standard does. This is just example of hazards that we have in our. There are a lot of other too. So there could be a high electric voltage that would give an electric shock to the user, or bacteria. You could when you're working with human whole blood or animal whole blood as well, there's also always a risk that the blood is contaminated, and you can have some kind of disease contamination to your own blood if you have. So you need to take that in account. And of course, some kind of hazard could be that there is a wrong result, and so on. The next piece is the user tasks, and these are connected then to the usability FMEA, and we have a document we call task specification, in which we break down the user scenarios into tasks. This is just a simplified presentation of that. And each task we analyze what kind of hazards could, or what kind of reasonable foreseeable misuse or abuse could be made by the user. And each of those leads to a risk item in the FMEA. And here then we finally have all the different kind of FMEAs or FMEAs actually, since we are also addressing criticality in this system. We have the usability, where user actions, as I told you, are analyzed. We have the design, different functions, different structures, subsystems, components, and so on. And then we have the software, which has its own characteristics. And we have different FMEA live docs for these. And they contain risk items. But in our system, the risk items are quite similar, nearly identical. And they contain the attributes that are listed here. So it's the life cycle phase, like design or transport or reasonable foreseeable misuse or so on. Then we have the hazard, and this is a link to the document I already talked about. We have the element for analysis. That could be a task step in the user task, or it could be a design feature in our design descriptions. It could be a software item or a process step. An element function or requirement is an element that is linked to this element that we are analyzing. So there's some more possibility for a breakdown of this analysis to be made. And then we have the key information, the sequence of events leading to hazardous situations. So we describe the sequence of events from the root cause to the step just before the hazardous situation. So a hazardous situation could be user gets contaminated from a sharp needle that is part of the system. And the harm would be that the user is contaminated, and if you get HIV, for example, then that's a severe disease, and that has a high severity of harm. And the higher the severity of harm is, the more important it is, of course, to find mitigation that eliminate or makes the probability less smaller for that severity, for that harm to or hazardous situation to happen. We use a term we call pre-mitigations. These are mandatory standard requirements that we know that we have to implement in the product. We could, of course, say that we take this in the ordinary mitigation, but this saves time and efficiency. So one of the tricky things when you go to a risk assessment meeting is to understand what is the object that we are risk assessing. And this is the pre-mitigation field is to support that understanding. If you so we have the basic design, and then we put on the mandatory standards, and that is always our object to assess. Indications are indications on the situation. There might be smoke. Well, that will affect the risk assessment. So then we can document it here, just to support understanding of the risk result, perhaps a year later or so, because it's a lot of details. It's impossible to remember actually. So we try to provide support for those situations. P1 and P2, there are probabilities. P1 is probability of hazardous situation occurring. Well, will there be smoke or not? Or P2 is the probability of situation leading to harm. What is the probability of the people in the room when the instruments us to generate smoke? What is the probability, for example, for them to get burnt or if to get harmed by the smoke? And at the last stage, the probability of harm is summoned by the P1 and P2 using a matrix that we have defined in our risk management plan. And that finally, together with the severity of harm, leads to a risk level. And depending on the risk level, so we have 3 categories: low, mid, and high. And depending on that, we decide is a mitigation necessary or not. And if we land on mid or high, then we need to do some risk control measures. So then we need a requirement that describes that risk control measure. And then you have the last step, which is the evaluating the residual risk. So when we take account the initial assessment, we take in account the risk control measures, then what probability of the hazardous situation occurring, and what probability of hazardous leading to harm. So different kind of mitigation can make these probabilities smaller. For example, if we build a protection, I had the example of user hurting themselves on the needle. If we make a protection that you can't hurt yourself on the needle, then the probability is very low. Or if we have a situation, but we want to provide an alarm, another kind of situation, then the probability of hazardous leading to harm will be smaller, since there is an alarm that will alert the user, and so on. And the aim is to lower the risk using risk control measures so that we can have an appropriate risk level, and in the best of the worlds, eliminate the risks. Okay, so there is a lot of information in these attributes, and of course some risk rows are similar to each other, and you really should have a similar risk assessment level with risk items or hazardous situations that are similar to each other, and also it's good to have a better risk overview, and you can't see this now, so I'm aware of it. So also many people are used to work in Excel like a matrix, so they are used to work in risk item rows like this. So each row here is a risk item, and very often you have hundreds of rows like this. So you really need to have some kind of view where you can sort out, or you can filter, so that you can get the appropriate information on the screen. And this is something that Taipova had built in the medical model, and that we have optimized for Boule. We have only changed some headings here, and perhaps added a column and removed some other columns, but the basic information is the same. And this is an interactive view, so you can work in this view. You cannot directly write in these cells, but you get a sidebar here with the attributes for that row, and so you can fill, and you can save it, and you can see the result on this matrix then. So you get the overview. You can also see that some of these are blue. Perhaps you can see this on your screen, and these indicate links to other objects. I will talk more about that in a time. So the first part of this matrix is the risk analysis and risk evaluation. Then we have the risk control, and then we have the residual risk assessment. So this is how you can find all the parts in this risk assessment. And here you can see the same headings that I was talking to when we looked at just one risk item. And perhaps you can read a little bit more about the risk item information here. This is presenting just the risk analysis and risk evaluation part of that interactive risk view. Yes, let's move further, and then we have the other part too. I just zoomed up these views a little bit at least. So you remember the information model, and that there were links between the different documents and work item types. And here you can see that the interactive risk view, it presents each risk item that we have established in an FMECA document. Then we can present it here on the row, and we can present the attributes. So all the black ones are attributes that are part of this risk item. Example, item number 2 here. And then we have the link to hazard item that is situated in the document hazard identification. Here we present that information, so you can see the identifier and the heading of that. And element of analysis, there if it's a use FMECA, then we have a task that we link to that. If it's a design FMECA, then we have a function of some kind. So we have design descriptions where we document the design and where we also define functions that we then analyze. Then if we need a mitigation, then we would have a link here to a requirement. And as you can see, if you remember towards view, we had a similar view. That view also contained the verification parts. But we can do this in a different way, of course. There are traditions where you want to have the verification proof in this same matrix, but we have chosen to have to not have them here, since we want to make this an approved document when the assessment has been has come to this stage. So we prove the verification of the risk mitigations in a risk trace matrix, where we have the risk assessment items here. Now this information is not really correct. These are not really risks, as you can see if you read that text. But they now in this presentation they symbolize the risk assessment items. So here we can see that this risk item, it didn't really have a mitigation here, and here you could see that this risk item, well, it has 2 mitigations, and then you can see that each of these mitigating requirements have test cases, and they have passed in the latest test results. So we are using such a matrix to prove that we have tested all the mitigations, and this is a really strong way to show an auditor, but also ourselves, what test cases have we not yet run, what mitigations lack test cases, and are they passed, or do we need to reconsider if they are still valid because we have changed the design. So there's a lot of information in this picture, and it's a really good help to get a good overview. To do this manually takes a lot of time, so there's a really big improvement in efficiency if one is working with risk trace matrices. It can take a couple of weeks to make for a little bit more requirement mass such a view. Okay, so that is where our risk area actually ends when it comes to the Polarian implementation. We have not implemented this yet because we are now moving to the verification part, and we have waited with the implementation of this risk trace matrix onto that phase. And here you can see an overview of the process when we have implemented the risk management for ISO 14971. Of course, we start with defining information models, so we get the logical flow of information, defining the way of working, and that incorporates how are we working with the work items. As you saw, the interactive view, it consists of a lot of details, how we form our routines, how we do our reviews and approvals, and so on. The items in Polarion, we have been configuration for this area, are the hazard items, task items, function items, and risk items. They are work items that are situation in live docs. So we have also generated templates for hazard identification, task analysis specification, risk assessment, report, that is the one containing the risk items, and design descriptions. And then the views for Polarion matrix views, then we have are using the live report mechanism and generating the trace matrices for different purposes. And then, of course, we have Polarion process documentation and Polarion working routines that we need to establish so that users know how to do. And then we are validating the whole environment, work environment of the risk area in Polarion. And I just have one last or second last picture describing how we validate Polarion. We of course try to utilize Polarion for the validation of Polarion. We cannot use it as a formal tool yet for the complete validation, but we export the areas, for example, test specification and test reports. We export to our documentation system as PDFs and do the review and approval in that tool, the formal one. But the areas where we have already validated, we can use already as formal validation tool for Polarion. We have divided the whole Polarion work in smaller areas. We have a situation where we need to be able to work with these areas in a big project, and these areas are synchronized with that project, and of course also scale to the resources that we have now allocated to this work. The inputs we are using is a validation plan requiring specification for Polarion functionality, Polarion that for the field in question, Polarion risk assessment, and Polarion test specification. And that leads to the implementation and also the routine that explains the usage for users and different details that we need to establish in order to have the whole process working. When that all is done, we execute the test cases, and as an output we of course have test reports, and then we summarize everything in a validation report. And once that is approved, we have the release for use, where we provide a training and then we give the access rights to the users. So and it's yeah, the devil is in the details. So it's good to have expertise. It's good to have people that have experience from before. And for us, it was good to have a type of us medical template as a basis for this work. Of course, you need to have allocate dedicated resources. This is not something you do with your left hand, as we say sometimes. It's something you really need to concentrate, and someone needs to focus on it, because there are very many details that need to be discussed and also synchronize with your quality department. So keep Q close, I believe. And most tasks, they have more work than you expect when you start. But it's a work that is really worthwhile, and I recommend everyone who is thinking about this to really think about this and learn more about that, so you can start using a requirements system that provides you great efficiency and control of your product. Okay, that was my final words. Thank you very much. I hope you have learned some information that is of use for you.